Hello and welcome to another one of D's ADD videos. Today we're going to introduce the concept of trigonometric substitution. This is a technique of integration that's more advanced than others and will require you to have a solid foundation on the other techniques of integration such as U substitution, integration by parts, any trig related identities or algebraic manipulations should be down pat before trying these. Trig substitution is one of your big guns if you can't do any of the other types of integrals. So when do I actually use a trig substitution? Well, you're going to have to try other techniques. Like I said, first you're going to try algebra or some trig identities to manipulate your problem in terms of something else. Okay, and hopefully your new appearance will be much easier than your original problem after doing some long division, separation of numerators, or using some Pythagorean or double angle identities, whatever the case may be. If that doesn't work, then you have to try U substitution. If that doesn't work, then you have to go on to integration by parts. Okay? These are kind of like, the pawns, then you have the slightly bigger guns, the even bigger guns, so we call these like the cars with the machine guns on them. And then these could be like the tanks, I guess. And then the next wave would be something bigger, right? Well, one of the bigger things that you might have, the airplanes dropping bombs or whatever the case may be. I hate the war metaphor there because I do not believe in war or violence in that manner. But that's a totally different discussion. It does work as far as trying to explain how to approach each integral. So if it doesn't work, any of these three techniques, if they don't work, then you're going to look for one of these three patterns. All right. Either the pattern is going to be a squared minus u squared, where a is a number. It doesn't have to be a perfect square. You can square root 5 and get root 5. U squared is some sort of variable. U squared minus a squared, or u squared plus a squared. Each one of these results in different type of trigonometric substitution, as you can see. All right. Plus one's easy to spot because it's tangent immediately. Number first, well, the trig functions usually list sine as the first one. So the way I remember when the number's first, it's sine, because sine is first. And when the variable's first, it's secant. All right. However, you got to memorize it, And then what you do is you choose your correct substitution. You find out what your du is by plugging in terms whatever your u and a are, and then taking the derivative of that. Then after that, you're going to have a brand new integral. So you're going to have to try these steps again, where you try either trig identities, u sub, probably not going to be algebraic manipulation, then by parts, or one of the special techniques as a trig integral, partial fractions. I doubt you're going to see partial fractions within a trig sub. It might happen. Or some sort of table integral. All right? So this concept video is pretty short because you can't really explain this too much without really doing problems. And that's the key for pretty much anything you're trying to learn in these classes. The more you practice it, the more second nature it will be. So always practice, practice, practice. I hope I've eliminated enough doubts for you to just at least try some basic problems. And you can check out the example videos. As always, pause the example videos for best results. Thank you. I hope you have a nice day, and I appreciate you watching.